Hello. In this video we will modify the code so that we can have multiple lists, because in the last video we had this global root variable and all the functions were using this one root, meaning that there was only one list in use, and even in the main function we were using this same root everywhere. So there was only one list, but now we want to have multiple lists, like say we want to have 5 lists at the same time, like 5 list objects. So the way to do is that we will take out this one, this global root, and we will create a new struct which, let's call it linked list or just list struct, and this list contains this root as a member. And I will initialize it to nil straight away here. So now from this moment forward, we can create multiple lists. So we can create like this. So list 1, like list 1, and then we can create list 2, and so on. We can create multiple lists. So they are objects from this struct. And both of these lists have their own root. That's the point here. So list 1 has a root and list 2 has its own root. So now we can say list 1 root like this. Then we can say list 2 root. So they both have their own root and they are independent of each others. Okay, so what we need to change to the last code is that we need to add this linked list pointer to each of these functions which are using the root. So if we go them one by one, this create new node doesn't use the root, so there's no need to change this one. But insert front is using this root over here, so we are adding this list pointer here as a first parameter, and then here in the code we need to say list root. It used to be like this. It used to be in the old code was like this, the global root, but now we are using this certain object and its root. So the list is given as a parameter. So which list? This one tells that which list we are dealing with currently, and this list's root. So I added this one all over the code now. And the other thing I improved a little bit this code is that I added some security here. So I'm checking that these pointers, all of these pointers, are correct, because if they are nil and we are calling this function, this code would cause the program to crash. So I'm checking that if list is nil, then just return, don't do anything. And here again, print list, we need the root here. So I added that this list's root, we are printing this list. And again we are checking, we are doing a couple of checks here. And here again, and now we are checking here that if the list is nil or the root is nil, then we can't find, then there is nothing to find. I mean, we can't find this, we can't find the last node in this case. So there are a couple of checks more here compared to the last code. Then add back, again list, here we are using the root here, and again checking the list here, insert after, and this was in the last code, was it? Insert after, I think it was. So again we are checking the nil case here, and then we have find first, again checking the list and also checking the root. So if the list is nil or the root is nil, then we can't find this value. It's not possible to find this value, so we are returning nil, meaning meaning for the color that it was not found. Here the same thing. If the list is nil or the list root is nil, the list size will be nil. And this function, in the last video there was one couple of mistakes, I think, actually, so I corrected this function now. Yeah, the first thing is here that we are checking this one, so that if the list is nil or the list root is nil, then the list size is 0, so we are just returning it. Otherwise, we know that there must be at least one item in the list. That's why I'm initializing this size to 1, the counter to 1, so it's at least 1, and then we are checking that if it's more than 1 here. So what we're doing here is that we are saying that if I make this window, if I make this window a little bit smaller, so maybe we can look at the picture a bit here. Look at the picture, this picture. Okay, in this case we have 3 items. So what happens in this case would be that we are here in a root. So we know that we have at least 1. So this is the at least 1 here. So we are first in setting just like that. So first we will initialize this current pointer to point to the root, list root, which is this one. So now it's pointing to the first node, and if this current is not nil, okay, let's say that there was only 1 item, okay, but it would still go here, sorry, it would still go because this current would point to the first item, so it still would go inside here. So we will in any case we would go here. But let's say that we have only 1 item, only this one, and we would not have these other nodes here. In that case, this next would be nil pointer here, because the last element always have nil as a next value. So this would be true. So current next would be nil, and we will jump out of the while loop, and we will go here and just return the 1. But let's say that we have 3 items, so in that case the current next is not nil, so we will go inside here and we will update this current to be the current next. So current next is the address of the second node, so current becomes the address of the next node, meaning that current is now pointing to the next node. So we can increase the counter by 1. We know that there are at least 2 items because there is this because this is now pointing to that 2 items, so there must be at least 2 items. And then we continue the while loop, and now we're checking this. So current is now pointing to the second item, and this current next is this one, which is now the address of the third item, and it's not nil. Again, it's not nil, so we go inside and we are checking that if current, we are updating the current to be the second node's next, which is this one. So now it becomes the address of the third item, so current is now pointing to the third node, and we will increase the counter by 1 because we know that there are at least 3 items now. Then we go here, and now the current next, because current is now pointing to the third node, but now we can see that the next is nil here, meaning that this becomes now false, and it will jump out of the while loop, and we come here, and the size counter was 3, which is correct. Okay, so that's how I modified this. Now it works, this function. And so those are the functions we had last time. Now I will add now a new function which is quite important here is to delete nodes, because we didn't have any delete functions. The first delete function we need is delete all, because we need to delete all the items in the list. And again, let's say that we create a couple of lists in the main here. In the main we create a couple of lists, but at the end of the list, if we don't delete them, then there is a possible memory leak, because we created all kind of nodes, lot of nodes, and if we don't delete them, then there's a memory leak possibility. So it's good to have this delete all, which deletes all the items from the list, all these all the nodes from the list. So the list becomes empty. And let's do this one now. And okay, so again we will pass this list as an argument here for this function. So which list, so this one tells that which list we are dealing with now. And again we are checking that if the list is nil or the root is nil, then there is nothing to delete, and we can just return. If the list is not empty, we will start deleting the items from the beginning to the end. So we will first delete the root item, root node, which is this one, and then we will delete this one, and so on. And we will all the time need to update this root, because if we delete this first item, for example, now the root must point to the second item, and when we delete the second item, then the root must point here, because let's remember that root always must point to the first element in the list. So we need to keep updating this root if we delete like this. If we start deleting from the beginning, then we need to always update the root, and that's what we are doing here. So I will create this temporary pointer. I will call it node to delete, just to keep the code clear here, that we know that which one we are deleting. So the first node to delete is the root node. So we want to delete this one first. And maybe if I show the code and the picture, try to show them at the same time. Again here, like this. Okay. So okay, node to delete is the first item. Then on the next line I will update straight away the root pointing to the second item, because we are going to delete this node here. So I will update that the root is now the current root, and this next is pointing to the next node. So we can just assign this next to root. Then root will point to the second item, and that's what we are doing here. And then we are doing this while loop, which is gonna delete all the nodes. And we are doing this while the node to delete is not nil. Obviously, if we are deleting node which is nil, we can't delete it. So we are deleting as long as there is a node which is not nil. And the first thing we are doing in this loop is that we are deleting the node, and in the first step it was this one here, and now we are deleting it. So this line deletes this one, but it's okay because we have already saved the root, the new root, so we can safely delete this one now. And the next node to delete will be this list's current root. What is the current root? Well, the current root is now this one. It used to be this one, but now it is this one because of this code here, we change the root, so now the current root is here. So now the node to delete is the new root, which is this node here, and if this root is not nil, then we will update the root, because in the last video I mentioned that when the root in here, when the root is nil, that means that the list is empty. So when we keep deleting nodes one by one, there will come a time when the root of the list will be nil. And when it's nil, that means that the list is empty and there is no need to delete anything anymore. We can't delete anymore. So here I'm checking that if the root is not nil, then we can update the root. And in this case we were here. So now the new root will be this next here, because this next here is pointing to the third item, which is here. So we are saying that the current root next, which is this one, we are assigning this current root next next to be the current root, to be the new root, sorry. So the new root here will be the current root's next value, which is this one. So now this line causes that the new root will be the node number 3, but we haven't yet deleted this one, this guy here. So but it will happen soon. So end of the while loop. So now it will go here, and it says that while node to delete is not nil, and it's not nil currently, it's pointing to the second node. So this line here deletes the second node now, and we are safe because the current root is pointing to here now. And the new node to delete will be the current root, which is pointing to the node number 3. So we have one more node here, and now we are saying that if list root is not nil, well, it's not nil because it's pointing to the node number 3, so we are still going inside here. The root will be the new root will be the current root, its next value, which is this one. Okay, so now it changes. Now we get nil here. So the list root becomes nil now, nil pointer. And now we come here again, and this is pointing to the third node, so we still go inside, and now we are deleting the third node, and now we are setting that node to delete is list root, which is now nil. So this one becomes nil, and this is also nil now, so we don't go here to find the next anymore, and we come here and this is nil, so that breaks the while loop, and that's how we deleted all the items. Okay, and that should work. Let's test this now. I will take out all of these. I will take out what do I need to take out? No, I don't need to take out anything. Let's just test now this current situation. So I'm creating two lists here, list 1, list 2. I'm adding items to the first list, these items, and then I'm adding to the second list these items. Then I'm printing both of the lists, and yes, let's try this one. Okay, so there is 5 to 17, 5, 10, 15 and the sizes of the lists and so on. Okay, so let's now delete delete all from the list 1, for example. So it should print empty list now. And there we go. So the first list is empty list and the second list is printed here. So this seems to work. And at the end of the function we want to delete obviously both of them so that no memory leak is occurring. One more function we might want here in this video. I think we want a function which is able to delete one of these nodes. Let's say that we want to delete this middle node, node number 2 here, meaning that this one would point now here. So let's do that one lastly here. I've already done that, and this is the longest function I've done so far, but it's all very logical, so we should survive this. So here it is. This node deletes. This is the name of the function, delete node, and this is the list which it from where it will delete that node. This is the node we want to delete, so we will pass the pointer to the node we want to delete. For example, if we want to delete the number 2, we will pass the address of this node. And the third parameter will be here an optional parameter, node before. Why do I pass this node before? The reason is that okay, because we need to set this node 1. When we delete this one, we need to set this next now pointing to here, because this is gone. So this one now needs to be linked to the third node now. So we need to update the node before as well when we delete this one. So we need to know the node number 1. But how do we know if we only have the address of the pointer to the second node? How do we get access to this node? Because there is no connection backwards. If we only know this node, we can't know what is this node, because this node doesn't know anything about the node before. It only knows the node after it. So the node number 2 knows what is node number 3 and even the values from there, but it can't get access backwards. So what is the solution for this? Well, what I did here is that I will give 2 options. If the caller knows what is the address of the node before this one, it can pass it here as an argument here. That's why I called it node before. Or if the user doesn't know what is this one, which might well be the case, many situations, in most of the situations probably, in that case the program will find it itself. So the program will go from the root and one by one go forward until it finds this one which is before this one. And we will see the code of this here later on. And in the header of this function here, I'm setting it initially to nil, meaning that if it's nil, it means that this function needs to find it itself. So the default value is nil, meaning that this function will find this node itself automatically. But if we pass this node to this function, it will be faster because the program does not need to find this one. So that's the benefit if we pass it, if we know it. Okay, so let's go and see how this goes. So first of all, we are checking that if the list is nil, or the node to delete is nil, or the root is nil, then obviously there is nothing to delete. So we can just return return from this function. There are a couple of special cases. There are couple of different situations here. The first situation is that we are deleting the root node. So we are deleting the first node here, this one. Okay, so if the node to delete is the root node, then we go inside here, and then we are checking first that is it the only item in the list, meaning that there is only one item in the list. How do we know that? Well, it's the next value. If this next value here is nil, that means that this is the last item, and in this case it will be the one and the last. So if it's the last item, then it becomes simple. We just set the root to nil. That means that the list is now empty, because if the root is nil, the list is empty. So the list becomes empty. And aha, I think I left here a mistake so far. I just found it now, because actually there are two situations here. Okay, if there was only one, we can do this one, and this is dealing with the situation if we have more than one. So we need to have an else block here. Else like this. Maybe I'll take this comment and put it here like this. So if there was only one item, then the new root becomes nil. The new list becomes empty. But if there are at least two items, then the new root will obviously be this will be the new root now. So we will copy this next value to the root here. So the node to delete next will be assigned to the root, and thus root is now pointing to here. So we are passing this node like this, and then we are deleting this node which we wanted to delete, and then we are just returning. Okay, so if it's not a root node which we are deleting, so we are deleting something after the root, which is this one or maybe this one. So first here we are checking that did the user pass this node before, because we will need that now. If it's nil, that means that we need to find. Let's say that we are deleting the node number 2 here. Okay, if we are deleting the node number 2, then we need to find this node number 1. So we are doing a search here, and so we are initializing the node before first to the root, because we need to start from the root and go one by one. So then we are saying that while this next is not the node delete, meaning that while this next is not pointing to the node which we are going to delete, and the node next is not nil, and so here we are checking that did we reach the last because we need to stop the search when we are reaching the last element. So here we are just checking another check. We are checking that did we reach the last element here. Okay. So we are going to the next node here. So we are just saying that so we are moving this cursor to the right. So the new node will be the next node, so this one. So first we go here, then we go here, and so on. So this one moves the node to the next node, and we are continuing this loop until we find this node to delete, or we reach the end of the list. And here we are checking that did we reach the end of the list. If we reach the end of the list, that means that we didn't find the node before. So that means that we can return from the function because we reached the end of the so we didn't find a node before. So there was probably, there's a mistake then. There's some kind of mistakes. This node to delete, we can't find that node to delete at all, because we found the last item, and we went to the last item, and none of them is pointing to this. So there was probably some kind of mistake. So we're just returning. We can't delete anything. Okay. And okay, and when we come here, when we are here, so now when we are here, everything is fine, and we have the node before. It's either parsed or it's found using this code. And now we need to just check that are we deleting the last element or something in the middle, because it's a different thing to delete the last element than, for example, this middle one. So here first we are checking that if the next is nil, meaning that then it will be the last element, because if this next is nil, we are deleting the last element. Sorry, this is if it's not the last element, because it's a not here. So if the next is not nil, that means that we are deleting one of these middle elements here, for example this one. In that case, we need to connect this node to here, because it used to go here, but now we need to connect the node before to the node after. Okay, and we are doing it here. So node before next is set to node to delete next. This is the node to delete, and its next is pointing to here. So that sets this one here. And if it was the last element which we are deleting, so we can just put the node before, which is this one. So let's say that, so if we are deleting this last element here, so that means that we need to set, because we are just about to delete this one, so we need to set this next to nil. And that's what we are doing here. Node before next set to nil. We have a new last node. And lastly, we can just, because now we have set all the connections first correct, for example this one, so now we can go on and go forward and delete this one now. And that's what we are doing here. Okay, and lastly let's test this one. So let's run this one again. Oops. So I will put here like this. So this was the situation without anything deleted. So let's delete this 10 from the middle here, for example. So how would we do that? We need this function called delete a node. So let's call it here after the print. So the delete node, and the first parameter will be the list which we want to. Okay, we want to delete from the second list here. So I will pass the address of the second list, and then we will need to tell that which node to delete, the pointer to the node. Okay, so this is the this is a thing we need to find. We need to find a pointer to this second node. How do we do that? Well, we already have a function here, which is this one, find first. This find first finds, as we can see here, it returns a pointer to the found node. So let's just find that node, and the return value of that should be the node we are interested in. So we say find first, and we put here the address again. We put the list2 address here, and then the value, okay, it's 10. We are interested about the node which has the value 10. So I put 10 here. Yeah, that's it. And then, so this one returns a pointer to the node which holds this value. And the last thing here is that, okay, we pass here nil pointers, meaning that we want this function to find the node before itself, because we don't have it here. So let's just let this function to find it. Okay, and let's now print this list after, before and after here. So this is before, and then we will delete the number 10, and then we will print again the same list. And let's see if it works. I hope it works. And there we go, it does work, because we have here, this is the old list2 5, 10, 15, and we are deleting from the middle, so we get 5 and 15. So that's all good work and working. So now we have pretty nice structure here, and this is also very much C code. But the next thing I would like to do here is that I would like to create a class, which might be in the next video at some point. We might want to do a class which automatically does many things, like deletes all of this stuff and manages the memory automatically. But that will be another video. Okay, thank you for watching.